Hey, happy Friday, all, and welcome to the Common Good Podcast. And good day, Earthlings. It's Earth Day today, Paul. Did you remember?
I did.
We built your calendar. Dan, did you remember it was Earth Day when you woke up today?
I remember it now because we talked about it yesterday.
Yes, that's right. Just yesterday. Yesterday was like Earth Day Eve, and we had to.
Very exciting. Yes.
Well, today, Earth Day, 52 years of some level of federal recognition that we live on a planet. So good for us. Give the Earth its due. Well, the part of the Earth that I am on is, I used to know the latitude and longitude of where I am. I don't remember that anymore, but I'm just half a block from the city of Minneapolis in Minnesota, in the United States of America. And it's cloudy, raining, and the Earth is being fed by its own moisture today where I live. Dan Deitrich in South Bend, Indiana. Good morning.
Good morning.
Look, you're looking very lumberjack today.
Got my lumberjack shirt.
Yeah, it's good. The beard, it's all come together. The framing. Did you have pancakes this morning with your own syrup?
Yeah. Flapjacks. Yeah.
Flapjacks.
Hey, a shout out to my friend who sometimes listens, but John Music and his wife Robin, they tapped their own trees for syrup in their own yard just miles from here. Like urban syrup. I didn't even know that was a thing.
Urban syrup.
Yeah.
I've seen, TikToks about people that do that and have wanted to do it, but
it's there's some in my kitchen right above my head. This is
urban.
Urban's bad. I would say first ring suburb syrup, which probably even makes it more of a miracle.
Yeah.
That's possible. And then out of Georgia.
Let's see. Latitude approximately 35, longitude approximately 85 west.
See,
35 north, 85 approximately. I don't know.
Dialed in.
Yeah.
Hey, Paul, we were
also in a first ring suburb.
Yes, also a first ring suburb. They are the place of a lot of us, aren't they?
Yep.
Well, a lot of things to talk about. We like to talk about the sky. We like to talk about the Earth, especially on Earth Day. It deserves its due. And we're also going to talk about the other things you see when you look up in the sky, which can be somewhat terrifying, and that being birds. Because, Paul, you are an astrophysicist, a pastor, a professor, and an avid birder.
Yeah.
Is birding ever a profession? Do people get away with this? Do they make it?
Yes, but not by just going and looking at birds and logging them. There are ornithologists out there who make a life of essentially conservation, trying to protect the habitats and so forth, particularly of migrating birds.
It's great to hear that we'll create a whole category of people that will work hard in their profession to protect migrants. That's
yeah.
We do.
It might not be human, but
doing with human beings, right? Maybe because the animals on this planet, and maybe the insects, I don't really know. I don't pay a lot of attention to insects. They migrate. Humans, birds, butterflies. There's just people and things do that very deal. All right. Hey, the other thing, Paul, just before we came on, I said, let's save this for the podcast. We were talking about cameras. You had said, hey, I need to get a new camera because, my camera's different. And we were chatting about, why our
not
computers.
Not just different. Yours is better.
Yeah, that's true. This is not about difference. This is just about quality.
Yeah, exactly.
I will say, though, Paul, that the thing, and this is a little tip for anyone who's interested in this kind of thing, lighting is as important as whatever the lens is that you choose for a camera.
So both of your faces are nice and lit up, and mine's sort of
dull and
exactly. Thank you for saying that.
So I have too many lights in front of me, but if I turn off just that light, you can see what just happened with just that one light off.
Oh yeah, absolutely.
Look at that. And you just turn on one more light, and all of a sudden there's a thing. I've got
now. What kind of light is it? One of those little ring light deals, or is that just a lamp?
It's a little ring light. So my camera is actually sitting in the center of it. I mean, it's better than a lamp because it just doesn't send light. I have this other one over my head. This is the trick. That over the headlight. It's right up there. When that one comes on, then it sort of lights up the top, and two lights. All of a sudden, people are like, "Man alive, that looks great." So
next time we do it, I will bring some lights in here from the lab next door.
There you go.
Okay.
We have some I'll bring some lasers in.
Yeah. All right.
Be awesome.
Well, so for some people, the cheapest thing to do, and sometimes you even just sit by a window or you open up a thing, or you always, and I don't know, I'm doing a like a lighting tutorial here on the Common Good Times podcast. But I guess
because you've watched 400 hours of YouTube videos about this stuff.
Normally, when I'm just talking to random people, at the grocery store about this, they really don't want to hear it. You do have to turn off the fluorescent lights that are around you. It is just rule one. Because the tone, the tone of the lights, like this ring light I have has different tones to it. So one in front of me. So if I cycle through different,
I can warm it up. I can.
Yeah. So you can see it's a little more blue and then a little more.
Oh yeah.
See that? Yeah. So anyway, the light waves out of fluorescence, and sometimes people have to work in their offices or they buy a fluorescent lamp or something. Ooh, those puppies are. Anyway.
Yeah. So incandescent.
Yes. And
or LED that can change warmth.
Yeah.
Yeah, that's the trick. You can drop that thing down. This
room is largely lit by fluorescent lights.
Yep. So you'll go a long way just with some non-fluorescent light shining at your face.
Gotcha.
And then when you buy that new camera that you thought, boy, maybe I shouldn't have spent $79 or $200 on a camera, then it really is gonna shine.
It'll be like, hey, good. And then I'll be glad that I did it. And you will too. It'd be like, God.
Wow. Thank you, Paul. Thanks for making this podcast better by spending some money on your camera.
For everyone just listening to the podcast, they're like, wow, this is incredible.
Yeah. So you sent me a microphone, but no camera. You can send me a camera too,
Did we send you a microphone too? Yeah. Okay. Yeah, good. I'm glad we did. Yeah. Okay. You just sit still there, Paul, and don't you worry about a thing, and just check your postal box. I don't know how they deliver mail there if you have to drive down the end of the road to get it, but you just keep your eye out. And your lighting solution will visit you.
Yeah.
Okay, but before we get to outer space, which I want to do, I want to get back to the birds because, Paul, I've seen you tweet these maps of migrating birds.
Yeah.
And I was fascinated. And so I looked up, you told me to check out Birdcast, and here we are.
So that's tonight. That's
246 million birds predicted
overhead
to be flying around tonight.
Yep, flying from the south to the north, going up. Yep, they're all passing through. And I read this great story about this woman who went to New York City to the top of the Empire State Building, and they have these lights that shine straight up. And she got up there with her binoculars during, I'm not sure if it was spring or fall, probably spring migration. Spring's a little more intense. And she stood up there and with the spotlights up in the air, she could just see like the river of birds flying north over the city. Yeah.
Wow. Okay, so they have a way to predict this, and this is a heat censored map that we're looking at. If people can see the visuals,
yeah. It's really based on Doppler radar, is what it is. What it's not heat. From. Yeah, it's not heat. It looks like heat. It looks like those maps you've seen about global warming, but it's not. It's really based on what's happened over the last few weeks and what's happened historically. This is a prediction, but you can also see it in live. So you can go on to Birdcast tonight at any time, and it'll show you the live data. Within a few minutes of it being taken, and it also sort of show you the arrows and the vectors of the birds, the direction, and it's all north these days.
And why are they primarily moving at night?
Because it's cooler. So they can stay cool. There's fewer predators, fewer hawks out soaring hunting. And also they navigate by using a number of different means, but one of the main things they do is look at the sky. They look at the stars.
Wow. Seriously. The birds are stargazers as far as we can tell.
They are. They absolutely are. No question about it.
It is fascinating that birds can travel these great distances, hundreds of miles, sometimes thousands of miles, depending on the species. and wind up at like the same little pond every summer.
It's absolutely incredible. It is incredible. There's so many unanswered questions. For example, I would just talk about hummingbirds because that's the first thing off the top of my head. I've got these hummingbirds in my backyard, and every summer they make new hummingbirds, right? And then in October they disappear and they fly down over the Gulf of Mexico, down Florida, and over the Gulf of Mexico to Belize, Central America. And
or to recharge their batteries because birds aren't real, and
it's like a tenth of an ounce bird flying over the Gulf of Mexico. But the thing is, you want to know something really crazy?
Yes,
is that they do it alone. They don't do it in a group. And these brand new birds who have not left, have not been more than 100 meters outside my yard. Somehow, when the sun gets low enough and the light gets right, they go south. Have never been there before.
Somehow nowhere to go.
First 3 months of their lives in my backyard, and then all of a sudden they go and they end up in Costa Rica.
Huh. And then
where all the other ones are.
And then do you think they come back to your yard?
Yeah, many times they do. I haven't exactly, banded the birds in my yard, but yes, they have been known, and it's not unusual for them to come back to exactly the same neighborhood, the same feeder.
Wow.
Did they ever bring you anything from Belize? Did they ever
That'd be cool.
And pick you up a little something?
Yeah. My hummingbird went to Belize, and all I got was this lousy T-shirt. Right.
Hey, how does a hummingbird? Like, do they just get up in the jet stream and get pushed? Because their little wings are so teeny. How do they travel?
They don't go.
Travel this far.
They don't go high enough to get into the jet stream, and anyway, they're going against it. At least in the fall, they are.
What?
I mean, they're going south in the fall, so that's
all right. So
jet stream runs up, northeast.
Okay, so do birds sleep while because do they land along the way? Like, are they taking little rest stops? And
they do. Some do. Some fly straight. Some have been known to fly from Alaska to New Zealand, 7,000 miles without resting.
What?
But there are birds that sleep while they fly. Yes.
Like they sleep one side of their brain? Is it that thing?
Yeah, they sleep one side of their brain at a time. Exactly.
Wow.
Yeah.
Which I should learn that skill.
Turn left or to turn right. Right. End up
and there's these swifts in Europe that spend their winters down in Africa, and they actually spend 10 months out of every year on the wing without stopping.
Goodness.
On the wing, that's a phrase for flying when in birding world.
Yeah, on the wing means flying. Yes.
Okay. Yeah.
On the wing,
as opposed to on the wire. Is that what's going on here?
Yeah.
Like it.
So they eat, they sleep, they mate, everything flying. They don't have chicks flying. That's what the 2 months are for. They don't have babies while they're flying. They don't do
egg drop
while they're flying. Yeah.
Honestly, at this point, if you had said, and then they can somehow sit on a nest of eggs with one half of their little bodies.
Yeah. But right now, go on.
How did you get into this birding? Like, I'll just say, birding feels like an entire world that it's hard to dabble in. At least the birders that I know.
Yeah, I've gotten really sucked in. When I was a kid, I was a big bird freak for like 2 years. I was a huge bird freak, and then I discovered Led Zeppelin and girls and stuff, and forgot about it. But then my dad picked it up, and he got a pretty good life list over the years.
A life list. What is
I'm sorry, that's a species that he has seen.
And that's like all birders keep a list. Like
we
this,
all
right?
keep lists. Yeah. And there's all kinds of different lists.
Really?
Probably the most esoteric list kept by any birder is species seen in dreams. But there's lists for the yard list, which is species you've seen in your yard.
Yeah.
There's a Georgia list, there's the county list, there's the U.S. list, there's the life list. There's so forth and so on. but yeah, the species seen in dreams is probably the most esoteric of them
So
all.
somewhere there's some bird gaggle of people together talking about their lists, and someone says, "Oh, here's I've got this." Maybe they pull it up and show it to each other or talk about it. How often in that birding world does somebody look at someone and go, "Oh bullshit, you didn't see the red wing blah blah blah"? No, I didn't. No way. That's got to be a common thing.
That's the thing about this is that so often birding is done alone.
Yeah.
But it's all based on, but the thing is it's kind of like science in the sense of you can lie about it, but somebody's going to figure it out. Because, if you did see such and so bird in such and so place, the bird's not going to just vaporize.
Someone else.
And once you announce this, and there's a thing called a rare bird alert, right? And so you put it in the internet, and everybody in the world knows about it, and everybody comes to see the bird, right? So if you're really serious about it, you'll put it on the list, and other people will come and see it too.
What is the rarest bird that's sort of ends up in the North Americas somewhere? What's the one?
California condor is really rare. Whooping cranes.
Really?
Yeah, they summer up in Canada and winter in Texas. And also a couple other points, but mostly there. So those are two of them. There's a woodpecker here in Georgia that's really rare. There's probably only maybe a few hundred of them. So those are the top three off the top of my head. There's probably some out west too that I'm not as familiar with.
Are any of those on your life list? Have you?
No, I'm not seeing any of those three. But the woodpecker is one that I could see because there's two places in Georgia where you can see it. Public. There's also, of course, some military bases where they've managed the habitat for this particular kind of woodpecker, but you can't go see them. But I suspect that it's called a red cockaded woodpecker, and I think I'll be able to see one in the next couple of years.
Why is the military creating a special place to attract the woodpeckers?
No, they're not. But what happens is the land is not publicly accessible.
I see.
But the military will allow conservationists to come on the property and to manage the property because you have to have this bird requires a very specific habitat. And so you sort of have to keep the habitat managed so the bird can thrive.
It's a real kept bird there, that thing, that little precious bird.
But migration is happening right now, so it's crazy. It's like taking all the birds and just mixing them up. You'll never know what you're going to find anywhere. Normally you associate a certain bird with a certain habitat.
Okay, so back to that image that we saw where there's tonight in air or on wing, there's 2.46 million birds predicted to be moving south.
246 million.
Oh, 246 million.
A quarter of a billion, yeah.
That's a better way to say it. 250 million birds are in flight over us. Are they all mixed up together too? Is it like public transportation up there? Like
Yeah, they pretty much are. They pretty much are. I think there probably are most species of migrants do migrate alone, meaning that not in flocks of the same kind. But there are some that do. But for the most part, they're all just kind of mixed up.
Wow. Yeah. So, okay. Where I live, the robin and I don't know, the blackbird, I really apologize for my I have zero birds on the bird list, on my life list. They're here in the spring and the summer.
Yeah.
Do those birds migrate? Are these Minnesota robins?
Yeah,
they just stand around and go.
Robins definitely are. They're what we call short range migrants. They don't go that far.
Okay.
But yeah, they're probably, I'm not sure where yours would be during the winter, but here in Georgia, we have them year round, but they're different individuals in the spring and in the fall, in the winter and in the summer. They're different individuals, but we always have them. So the population shifts up and down, but where Georgia's in the section where we always have some.
Huh.
So,
why do they come back? Do you have any idea? Like, why don't they just get down there and stay? Why the back and forth?
My understanding is that it's food. Oh, you're saying in this case, why don't they just hang out? That's a good question. I'm not sure
No,
why.
just any birds. Like once they leave, I guess it's like anyone who moves to the warm climate. Why would you? Why do you come back?
I
Is it
think
food?
I think it's mostly food. Yeah, yeah, and yeah, food is what I would say, and also the breeding grounds. I mean, where you raise your young, you know, a given species of bird can't just raise their young in any environment because the hawks are going to get it, or
Oh,
the river's going to flood, or something. You know what I'm saying?
Mm-hmm.
So there's certain habitats which are safe for certain birds, which would not be safe for others.
what about the hawks? Do they migrate too?
Some do. We have certain species around here. We have all year round and do not migrate. They're sort of permanent residents, but other species of hawks do. Most of them do, but they're not usually very long distance migrants.
Okay.
Yeah.
Wow.
Yeah.
And this is, are we at peak birding season? Is this the time?
Yeah, really between like April 15th and May 10th, something like that is it's pretty short and pretty intense in the spring. It's more spread out and kind of mellow in the fall. But
should people be looking out for it? Like, are there, I guess, other than just hearing new sounds, in your area?
Yeah, you'll never know what you'll see. You'll hear new sounds. And it just sounds different outside. I go outside now and I'm walking across campus and I meet somebody and they start talking and it's like, please stop talking.
You're that guy that's like,
hold it for 2 weeks and I'll talk to you. Or let's go inside because outside is too distracting.
All right. Well, if you're not already following Paul Wallace on the social media places where he does keep this all updated. And sometimes, Paul, when you're looking not just up in the sky at the 246 million quarter of a billion birds in flight any given night here in the spring, you're looking a bit further into the stars. And we like to do a little update. The James Webb telescope is coming into its own up there.
It is
a magical spot. What's our update on that little gem?
It's been at its sort of final orbit for a while. It's arrived where it's supposed to be and it's there and everything seems to be working. They've been checking it. They got an image or two of some stars, just to make sure that the basic system is functioning. There's nothing special, but they do show that this telescope is functioning. And right now they're letting it cool down because electronics and so forth will work better when things are colder, especially a system this sensitive. And the mirrors have to be cold. They have to be perfectly aligned. And to make the alignment perfect, you have to have it as cold as possible because the metal that makes the things up, that it tends to, as you know, expand when it gets warm and contract when it gets cold, and they're waiting for it to get sufficiently cold to where basically all that contraction is over.
And it got warm from the journey. This is
just surface temperature of Earth is burning up compared to it's 200 degrees higher than where the telescope should be.
Yeah, we're talking very cold temperatures, right? This is 7 degrees Kelvin is what we're aiming for, which is minus 447 degrees Fahrenheit.
Yeah. I was thinking Celsius when I said a couple hundred, but yeah, in the Fahrenheit scale, it's 450 or so below zero.
And it's taken this long because it's been up there for weeks. We haven't had our podcast on with you here on Friday.
Yeah, right. Yeah, it does. It takes that long. And part of the problem up there is that there's no air to convect the heat away. It's all what we call radiative cooling. It's a vacuum. So your coffee cup will stay. If you put your hot coffee cup in a vacuum, well, number one, it would actually boil, which you don't want. But if it would cool off much more slowly than it would in a room with atmosphere in it.
Is that why when you blow on something it gets cooler? Is that essentially
basically? Yeah, you're letting the air absorb the heat and put new cooler air in its place, and that new cooler air absorbs the heat, and so forth and so on. The space telescope doesn't have that. So it does take a long time just to cool by radiate. It just radiates away the heat very slowly.
That's pretty cool.
Yeah, it is actually.
Oh, there you go. Look
But,
at that.
Hey!
Well played, Paul. Well played, little bird. Hey, I feel like we've talked about this, and somehow I've forgotten, because now when you said that the James Webb Space Telescope is in its orbit, is it moving or is it sitting still? And if it's moving, what is it moving around?
Okay, yeah, it's moving, but I do have to say this: that everything, in a sense, is moving, like relative to the sun, relative to the Earth. I mean, in other words, whenever you say, this is a little pedantic of me, you have to forgive me, but I am a science professor, so I have to say this, a physics professor. So whenever you say something's moving,
yes,
all you ever mean is that it's moving relative to something else.
As opposed to what? What else could
something? There's no absolute standard of rest.
It's an awesome phrase.
Do you know what I'm saying? I mean, there's nothing we can point to.
There's no absolute standard of rest. You are just going to be exhausted.
Yeah. Well, maybe that's my problem these days.
That's why you feel this way.
Yeah. So yeah, it's moving and it's orbiting. It's orbiting the sun along with the Earth. But it's at a point. It's in the direction opposite the sun, as you can see in the picture there. It's in a direction opposite the sun from the Earth.
And is it staying relative to the Earth? To Earth? Is it?
Yes. Yeah. It orbits with the Earth. It stays in that location relative to Earth, and it stays pointed away from the Earth and the sun.
Got it. And it's there. I mean, those of us who are watching this on the live stream can see this photo. I guess you could maybe look up a photo of it, but it's helpful for this imagery. So that it is staying relative to Earth, but then orbiting around the sun. And it's the gravitational pull of Earth with a couple little rocket boosters every now and again that keep the telescope
right in the sun. The combined gravity of the Earth and the sun, along with occasional little boosts to keep it in its location. Yes,
but it's at this point, the Lagrange point, right, where it's sort of at this near perfect tension of gravity tugging on it. So
it's at a point. The phrase is unstable equilibrium, and what it means, and sort of think of it like a ball on top of a hill. If you put it there perfectly, it'll balance, right? It'll touch, and it can run away from its resting place.
Mm-hmm.
But as long as it's really right on top, and every now and again it'll get a little bit off, but that's what the little rocket boosters do. They sort of keep it centered right there on top of the hill, so to speak.
Amazing. I don't want to take us too far back, but why is this such a big thing for a pedantic like science professor to want to say that there's no ultimate state of rest? Why is that a thing that is in you so much so that when someone says, "Is it moving?" you're like, "Well."
Yeah, that's the wrong question to ask around somebody like me.
Yeah, why? Why is that the thing that you?
Because it's number one, when you really think about it, it's kind of weird that all motion absolute is without qualification. All motion is relative. Okay, that's just and for hundreds of years, thousands of years, maybe even. There was an assumption that space was permeated by something called the ether.
Yes.
And that ether was assumed to be at rest.
Huh.
And that all motion was properly measured relative to it. Huh. But there is no ether, and this is one of the several lines of thinking that led Einstein to relativity.
When people hear there is no ether, I guess some people are like, "Oh, of course. What is this? 7th grade science class?" But other people are like, "Oh, really? I'm sorry. I thought things existed in the ether." Like that's because we still use that as a phrase, right? Out there in the ether.
Yeah.
Okay, so it sounds like you're saying there's still Scientists want to continue to make a point that they've been making for 100 plus years. There's no ether, so stop with that thing. But why does that matter for us? Like what in the world that you're in, the physics world, that feels like it's more than just a statement of fact. Like, hey, people should just get that right.
Yeah, no. I'm not really trying to be corrective in that sense. I'm just trying to share with you this idea that to me is a little destabilizing, a little disorienting when you realize that there actually is no absolute reference frame. For things to be at rest. And that when you say the car's going down the street, or you say the car's going 50 miles per hour, all you're saying is that it's going 50 miles per hour relative to the road underneath it.
That's right. Okay, I get
that's
you.
it. It doesn't mean 50 miles per hour in any absolute sense.
Right, because the car is also flying through space on the surface of the planet.
And also, the person in the car can say the street's going 50 miles per hour in the other direction. And that is equally correct, is my point. The person in the car is not more wrong than is not in any sense wrong whatsoever.
Wow. I am never paying a traffic ticket again. I'm going to be like
exactly.
Don't blame me. The street was moving 87 miles an hour.
It's kept going faster and faster and faster, sir.
In the other direction.
Give it a ticket. Give the planet a ticket. Give the street a ticket.
Is this fundamentally what a big piece of what the theory of relativity is all about? It's one of these things that without this relativity of motion, it's not clear that we would have gotten relativity figured out. Because I remember
it's an essential piece.
I remember getting into physics in the early 2000s in a different way by watching some of the great courses, videotapes, or maybe they were DVDs. So there was lectures that you'd watch, and they were explaining Einstein's theory of relativity. I don't know if it's just mythology that he would talk about this, but that the idea of sitting on a train and watching things go by, he realized, wow, things in the train are moving relative to other objects in the train, but they're also moving at another speed relative to things outside the train. I don't know. And maybe that's just a very beginner way to get your head around this idea.
Well, no, I think that's how I do it when I introduce relativity to my students. That's why I talk about getting on a train, because I think that, Einstein, given the kind of mind he had and the fact that he certainly rode trains all over the place, he had to have had that thought sitting on a train.
Sure.
I don't think it's just apocryphal. I think it probably really happened. Yeah.
I was going to ask you something else about that.
The rest thing.
Yeah. There was. I had one more little glitch in my brain that I was like, oh yeah, that reminds me. I was going to ask you about, and now I'm just thinking about trains and being a train.
Yeah.
Well, more happening up in the skies as well, right, Dan? Don't we have?
So one of my favorite things about space is just the names. Supernova.
I'm right there with you.
Supernova being my favorite, but they just came out with a new one to me. I don't know how long you've known of this, but they're calling it a micronova.
No, it's new to me as well.
Okay. So they discovered this new type of stellar explosion.
Yep.
What do you make of this? What's a micronova?
Well, apparently what it is I need to give you a little bit of a, this picture here sort of suggests the thing I want to say. It looks kind of weird. Like, for those of you who can't see it, basically it's a big old orange star with a jet of gas or dust coming off of it, going into this little, spiraling down into this little white star. Weird looking thing. Yeah. But the first thing you got to know is that most stars are not solitary like our sun. Most stars orbit other stars.
Like multiple, and heard of binary systems,
double stars, triple stars, quadruples, whatever. Yeah, that's pretty common in the universe. And you go outside and look up at night, and a really good fraction of the stars that you see that look like one star, if you could look at them up close, you'd see are actually two or more.
Oh, wow.
So it's really common to have these double stars. Doubles are the most common.
Mm-hmm.
But there's the closest star system to us is a triple system.
Huh. Why is this? Why do stars buddy up?
Well, because they're formed in pairs. Ours, not in pairs. Pardon me. They're like puppies. They come in litters. When they're born, they don't come in as individuals. They come in big groups. They come in clusters. That's how stars are formed. All stars are formed.
That's how a star is born?
That's how a star is born. And our sun is no exception, but it long since sort of left its little family of other stars behind.
Left the
Really?
nest.
It's a runaway.
But not all stars, when they escape, I mean, sometimes some stars are left behind in groups of 2 or 3. Some stars, when they escape, they're too closely bound up to another star to leave it, so they leave together.
Wow.
So
like family relationships here. So was our sun abandoned, or was our sun a runaway?
It's a runaway. It's a rebel. Stars are rebel.
Really?
Yeah.
Love it.
Yeah. So most stars are. So it's not that big of a deal.
And I'm assuming you would remind us if we got too, chummy about this with the stars, that we're speaking in galactic terms. So these stars are lots of miles away from each other. Is that right?
Oh yeah. Like in the picture here.
No, like if you say like stars are born together and there's 2 of them, pairs of them, or 3 of them, they're really quite far apart.
Yeah, well, some are and some aren't. Some are quite close together.
Like how close does close get? Like they almost merge into one same.
That has been known to happen, but more often they're probably about as far away, as the sun and Uranus or Neptune, maybe. Maybe further than that, but they can be that close as well and orbit each other pretty quickly.
There's the casual use of an astrophysicist scale, about as far as Neptune.
It's right around the corner.
That close. Oh, that's great. Okay.
Yeah, a few hundred million miles away from each other. Not that far.
So we knew about supernovas, which obviously are a nova that's big.
Super.
These micronovas, which great name for a band, are what? They're
they always occur in one of these double star systems. So that's why I went on about stars being in pairs and so forth, because they always happen in double systems like this.
Huh.
And stars evolve; they grow and they change over time. Eventually, they die. Okay, they have lifetimes, and some stars, when they die, they become something called a white dwarf. Our sun should be a white dwarf in 5 billion years from now. Okay, so a white dwarf.
So that's the end of it. So like when whatever's going on the Earth, X billion years from now, it's not anything like now. When the sun starts to move into its white dwarf stage,
right?
Right.
Yeah. Don't worry about it. It's not next week.
Okay.
An existential crisis for the entire human species. But
so this star system that we're looking at here is one in which one star has become a white dwarf, and the other one is a red giant. Okay, that big red star, for those of you who can see, that big red star is known as a red giant. And stars, when they enter the red giant phase, they get bigger and bigger and bigger and bigger and bigger. Okay, and they get cool, and they become what we call red giants. So we've got a red giant, and we've got a white dwarf. Okay, sounds like a Disney story.
So this is the pair, and they're moving they're evolving at different rates. So
yes, they're orbiting one another. One of them has become a white dwarf, which has extremely strong gravity. One of them has become a red giant, which is getting larger and swelling up bigger and bigger and bigger. And so what happens is eventually the white dwarf starts pulling material off of the red giant because of its strong gravity. As the red giant swells and gets larger and larger, some of its material gets pulled off onto the white dwarf.
Come on.
Not making this up.
Well, all this, we're never really sure. When you're not on here, we're always like, I don't know. I think those astrophysicists are just making stuff up. Nobody can ever check them. So,
well, do you know how we know stuff like this? Think of it this way.
No, I don't.
Yeah, well, this is a simple picture that you can take with you. Suppose you got 1 million people at random in one big photograph, and you took a picture of it.
Okay.
If you were careful and you looked at people, the young people, the old people, the babies, the women who are pregnant, all this, you would probably figure out a little bit about what there is to know about the human lifespan, right? If you looked at it closely. Right. Well, that's what we're doing. We have 1 million different stars to look at, and they're all in different stages of their lives. So by looking at that, we can piece things together and start to get a picture of how stars evolve. Even though we cannot see a single star evolve over its whole lifetime, we can see 1 million stars in 1 million random life stages.
Yeah.
Mm-hmm. That's kind of how we do it.
And how do they know that, okay, here's what's happening. This is now in a white dwarf stage. So it has a strong gravitational pull. So now it's going to start pulling elements off of the bloating red giant. Yeah. Because all that takes billions of years too. How do they know that's what's happening? Is that a explanation theory?
There's two reasons for that. One is that if our model of stellar evolution is right, and we have really good reason to think that it basically is, then this must happen, and it must happen a lot. In other words, this is not some weird kind of exotic thing that doesn't really fit with our model. Our model says this should happen and should happen a whole lot. Okay, so it's not an uncommon, although it looks weird, to people who have not, maybe, taken 4 courses in astronomy. It is not at all uncommon.
Got it.
And it should not be. If our model is correct, it should be common.
Well, it's so often that when we see these beautiful artistic renditions of something happening in space that go with a headline and a story like "Meet the Micronova," that astronomers have discovered a new type of stellar explosion. Then someone does some piece of artwork. I hear people who really know this world always be like, okay, that's an artist rendition of the thing. That's not real. We don't see what you're looking at right now. We don't see that. You can't take a picture of it and see that. They're trying to artistically describe something that happens over a long period of time. Is that true here? If you just looked at these 2 stars, would you see anything like?
I think you would see something that looks more or less like this. Yeah, I think that it's cleaned up a little bit. I think that the white dwarf would have more junk around it. It wouldn't be such a nice little donut shape around it like that. I don't think it'd be quite so smooth and clean looking. But I think you would see something that looks in its general features, yes, like this picture here.
Wow. And how many stars are there again in our galaxy? What are they talking about?
300 billion. 300
billion.
200 billion, something like that. Hundreds of billions. Just in our own little cozy Milky Way.
A little cozy corner, like
our little cozy corner.
Podcast.
It's actually a really nice galaxy. We could have ended up in a worse neighborhood. It's it's really pretty, is what I mean. It's one of those nice big spiral deals.
Really? Like we're in a first ring galaxy that's kind of nice, and it's right near the urban core.
Yeah.
The pressures of the concrete.
It's like being in a really beautiful mid-sized city. It's like, a really, really great college town. It's not the biggest galaxy out there, but it really is a nice one.
It's the South Bend of galaxies, is what I'm hearing.
I'll take your word for it. Yeah, I was thinking like the Chapel Hill of.
Haven't heard of that, but I sure have heard of South Bend. Boy, that's
also known as the jewel of the Midwest.
Jewel of the Midwest. I heard someone say that just the other day.
It was my friend, and he was making it up. But I love that it's
Doug. You don't know Chapel Hill, North Carolina?
No, I do. I was just being.
I thought you were.
Just being like,
there's no way. there's no way Mr. Traveler or Mr. World doesn't know about Chapel Hill, North Carolina.
Yeah, I'm very aware of Chapel Hill, and I'm very aware of the people who have the privilege of living in Chapel Hill, how they feel about it, and that they love it.
They love it.
It's not quite Asheville level of they're going to tell you, or usually it's how great it was, and then you pick some period of years from when you got there that it was really great. I mean, it's still great.
Before all the people from New Jersey moved in.
Before whatever it is that happened that made it, like you're not seeing how great it is right now because such and such happened. But it's really, if you get to real Chapel Hill or real Asheville or real,
real
Austin, Florida, any of those places, then you really do. Then you really do hear about it. Hey, anything else happening in the up in the skies that we should know about before we ask you what life is like on a university campus in the final days of the semester and how a professor like you holds it all together?
In about a month from now, I can't remember the exact date. I'll have to look this up, and we'll have to mention it again next time, a couple of weeks from now when I come on again. There's going to be a nice planetary alignment in the morning. So get up in the morning and you'll see like 4 nice planets, maybe even 5 naked eye planets all lined up in a row in the morning. So I'll have to do some digging around on that and let you know.
Hey, when you do your social post about that, make sure you write the word naked eye planet alignment. That'll just that gets people.
You like that, do you, Doug?
I'm just saying that people's attentions. I've been around too many naked people to be impressed. I'm looking this up. When is this planet alignment? 2020.
I'm thinking it's late May.
Okay, so
I'm going to be in Hawaii.
4 planets and the moon will line up in the sky this month, and that's in April.
Is it that imminent?
Well, it's saying Jupiter, Venus, Mars, Saturn line up kind of with the moon. And stargazers, get ready. Starting April 23rd, which is tomorrow.
Wow, I had that one off by a while. I thought that was next month.
Glad I looked this up. It's next day. It's tomorrow.
Well, that's my announcement. Tomorrow, there's going to be a planetary alignment, everybody.
Hey, big news, everyone.
That's tomorrow.
The perfect alignment will provide Earthlings. Wow, there's in this article they use the same joke. Earthlings, a relative and rare opportunity to see multiple planets in the sky with their naked eye.
Naked eye.
There it is. In fact, I wrote a book called Christianity Worth Believing, and the original title was Naked Christianity. That was going to be the original title.
And the publishers didn't like that.
Yeah, I don't know. I still feel like that thing would have been a bestseller if only. I think that's why I cued my eye on that. Experts say the celestial treat can be observed by gazing southeast in the direction of the sunrise about an hour before the sun comes out.
Okay.
So that's tomorrow morning, if the skies are clear where you're living.
Oh, you're an early riser, but you're going to have rain.
Look at that look right there. That look was perfect. Boy, you thought you had it going for you. You like to get up early, but you don't get to see it.
You're going to see nothing.
That's too bad.
So this thing this alignment happens, predictably, but doesn't last very long. Is that what they're saying? Like I can't see it Sunday morning or Monday morning?
You can see it. Maybe the moon will move a little bit, but the planets you'll be able to see probably for the next week at least. I would think.
Wow.
They just don't move that fast.
Mm-hmm.
Night to night. So you should be good for over the next week. But the moon will move a lot more quickly than the planets will.
So Barbara says in the chat, she says, most of my life I lived in New York. I've always believed the lights of New York are a reflection of God's gift of our beautiful sky.
But that's a thought.
I like that.
Yeah.
I heard a podcast the other day because there are some others if people didn't know. If you just go on an application, you can find there's other podcasts in addition to this one. And there's one of them I like to listen to called Stuff You Should Know. And they did one on the dark sky zones where in the world you can go where there's no external light, and it's a rare, like there's now a website that directs you to these places. It's extremely hard to find these dark sky zones. Do you know about this? About how hard?
No, but I'm not surprised that it exists. I've not heard of that particular one, but I
thought you could just drive, I don't know, an hour from wherever, any city, and you're out there and it's dark enough and you can see. But they're like, no. There's that doesn't count. I didn't know that. I didn't know the sky.
You can do pretty well, on certain nights, even on the East Coast, over here on the East, you can do pretty well. But I think what they're talking about is like Arizona quality, sort of.
Yeah. Mm-hmm.
Like northern Arizona quality, sort of.
There's some. Does Georgia have a barrier island? Are there? We have maybe 12 to 18 of them. Apparently, one of those is one of these
probably Cumberland. Cumberland is one that's just not developed at all. It's basically there's a couple of sheds on it and maybe a couple cabins, but no real development. Well,
Barbara, when you get up tomorrow morning, go look southeast just before sunrise and see if even with the New York lights, you can see Jupiter, Venus, Mars, and Saturn all.
Should be able to. Even from New York, you should be able to see all four of those.
And when I get up, if the skies break open and they can see the sky, are these just going to look like brighter dots in the sky?
Yeah, they're brighter dots, but they're all going to be in a line.
Okay.
So they're not just scattered. That's the thing. It looks like a little pearl necklace or something. They're all kind of laid out along a single line, which is nice.
Well, I got something to do tomorrow. I didn't know what my day was going to entail, but now I do. Today's Earth Day, tomorrow's Sky Day. So
vaping up.
All right, astrophysicist, pastor. Hey, how was Easter for you?
It was good. It was my birthday.
Nice.
Easter fell on my birthday this year.
Also, my daughter's birthday. So
hasn't done that since 1960.
Your daughter's birthday, Dan, was also
Easter. Yep.
Also April 17th.
Mm-hmm.
All right. I haven't met many people who have the same birthday as me.
It's a good day.
Yeah. And birthdays aren't evenly spread out either. It's if you look that up, there's a funny thing about that somehow people.
I'm guessing there's a peak around September, October. I'm saying that because people spend more time in bed in the winter, and they're
we're just in bed. What else is there to do? Let's make a baby.
Exactly. And when you got more hours, and you tend to stay under the covers more because it's cold.
Yeah, I did.
I don't have to explain it to you.
I did see that you wrote that in your lifetime, Easter, because it's a movable holiday, had not fallen on the 16th of April?
17th. Yeah, it had not since 1960, and I was born after 1960.
Because Easter is like the first Sunday after the full moon of the spring equinox or something like that, right?
First Sunday after the first full moon after the vernal equinox. So we could do a whole show on that. It's a mess. The story of that is really interesting, and it's actually kept astronomers in business for a long time because the church wanted to know when the heck Easter was going to be, and for a long time you couldn't just Google it and find out.
Someone had to say this is when the spring equinox is always the same time, but it's that full moon business.
Yeah, well, the spring equinox varies a little bit too by a day or two every year. It wobbles around a little bit. Calendar. We can do a whole show on the calendar. It's crazy.
Well, let's get that on the calendar. Hey, you said you had to go by the top of the hour.
Yeah,
we have 1 minute left, so we're going to let you go. All right. Farewell, astrophysicist.
Pastor. Bye, everybody. Good talking to you.
See you later.
See ya.
Bye.
Hey, all. Thanks for sticking around today, talking about the sky and the birds and all the things in the sky. Dan, I know we joke about this a lot. That is any of this stuff actually real? And I believe it all is. I don't have any true doubt, right? That's what a white dwarf star is with a red giant, and it moves matter, and that there's a space telescope sitting out there. They found the perfect spot of gravitational effect in the sky and landed a giant metal piece that's cooling down so that it can take an infrared light from the furthest distances away that humanity's ever done before. All that's, yep. It's also so mind-blowing, like we talked about with Randy Woodley yesterday, that I don't know any other explanation about how the world works. You know what I mean?
Seems it feels equally plausible, yeah.
Yeah, that sometimes we think like, oh, people make up these stories about what's going on in the world. And if they just follow science, it would just be so much easier. Well, it might, maybe, but it's also just equally as mind-blowing and stretching and just gobsmacked with the series. I mean, just the bird part of that whole thing. We don't really know
how birds get places.
Like, how did that get here? So it's easy to think, oh, in other periods of time of human history, people had to make up all these stories to explain this stuff.
Yeah.
Well, they're no more fanciful than, oh, what's probably happening is that somewhere in a bird brain and maybe somewhere with some pre-cortical frontal cortex ability in a bird, they can follow gravitational electromagnetic poles and maybe a key off of a star for a hummingbird to land back in your yard.
Yeah, that blows my mind.
And the birds are just doing it, 246 million of them tonight, just on their way,
zipping around, knowing exactly where they're going. I can't get around my own town without Google Maps.
Excellent point. All right. Well, mine's sufficiently blown. Yep. Okay, y'all. Get up early tomorrow. Look at the star alignment or the planetary alignment, because it's apparently really something. Is that it? We done?
That's it.
All right. A good